All right, we are at the last section of chapter 13 is the variance and standard deviation. So once again, we're going to discuss not this the statistics called central tendency like mean, median, and mode. We're going to talk about kind of like how spread out the data is. So let's look at some data. All right, get my little pointer ready. Boom, boom, boom. All right, so we've got a number line 1 through 14. The data points are the red ones, so x1, x2, x3, x4, x5, x6. So the data here is 1, 4, 6, 11, 12, and 14. And maybe that's the number of fish that I've caught on my last 6 fishing trips. And maybe that's a big lie, but let's just go with it. All right. So if I want to find the average, then I add them all up and divide by 6 and I get 8. So 8 is the mean. So wow, I average 8 fish every time I go. All right. Now we might want to know a little bit about do you some days catch 7, some days you catch 9, or are you that weird where some days you catch a 1 and some days you catch 14. So um, yeah, we'd like to know a little bit more about it. So what we can do is I want to visualize this for you. If we go, so we're kind of thinking about how spread out the data is from the mean. I think that's a good way to do it. So you kind of have this distance to the fourth one there. You have this distance to the third one. You have this distance to that one, and you have that distance. So you kind of have all these distances set up. Let's do one more in there. So maybe we can kind of look at all those lengths and maybe average those lengths. Well, there's no real formula that works because if I just say, hey, just take the mean minus, all the data points, some numbers are going to be positive, some numbers are going to be negative. And when you add them all up, you actually get 0 because it's the mean for a reason. It's kind of like right there in the middle. So man, maybe if we squared each one, then they'd all become positive, and then divide that how many there are. So what I just said there is maybe we take x1 minus the mean. So we're going to use this. Um, I'm going to discuss this in a little bit. That's mu is the name of that variable, and that represents the population mean. So maybe we'll just write that. That's the population mean. And X bar is usually considered the sample mean. Is there such thing as a population mean? Can we really get the entire population data? Or do we just say, all right, all 16-year-old boys' heights? Do we really measure every single one, or do we take a sample? And really, samples where it's at. So X bar is certainly, but what happens is we just say, you know what? Let's just talk about the 16-year-old boys in this classroom. Okay, so we can kind of like focus just on them, and that's all we're going to talk about. So we can kind of consider the population. So those are going to be back and forth. The sample mean is used to estimate the population mean. So they're kind of like what you'll see is that they're interchangeable as if we're relaxed. They are absolutely not if you're a statistician. Okay, so it does get a little dicey, but when you're first learning, you can kind of do this. But please understand, in your heart and soul, there is a big difference between population and samples. All right, so so what we're going to do here is we're going to take that data point minus the mean, find the difference, and we're going to square it, and then maybe add it to the next difference, square that, and then keep doing that until we get to the sixth one and square that. And then let's divide it by how many data points do we have? This is 6. And this is actually going to be called the variance. What's the symbol for variance? It is lowercase s, or sigma squared. So that right there is the variable that represents variance. It's just weird, isn't it? It's just weird. So that's all there's to it. So we finalize this with, it's really the sum of all the data points x sub I minus mu squared over n. And we say that's equal to the variance. All right, so if you want, you can look, and they have it all pretty here for you. There we go. So that's what we just discussed. We got sigma notation, we got the variable, that's all good. So there's another thing called the standard deviation. And the standard deviation is just the square root of the variance. So once you find the variance, then you take the square root and you get another statistic. A statistic is just a number that represents the data. That also kind of represents the spread. If you look at the numbers here, if you're squaring all this, you might get, like, the mean is 8 fish a day, but the variance might be like 16 squared fish. I mean, what does that even mean? Weird. But we take the square root of that, have 16, we get 4, and we take the square root of the units there, and so we say 4 fish. So we might say it has a mean of 8 fish a day with a standard deviation of 4 fish. So you're kind of visualizing the plus or minus sort of idea. So let's just leave it at that. It's not plus or minus, but it kind of says there are days where I catch a lot less than 8, and days I catch a lot closer to bigger than 8. If I had a smaller standard deviation, still the mean is 8, but maybe 1 is the standard deviation. It's saying that I'm much more closer to catch around 8 every day. All right. Fancy little notation for your notes. All right, so let's do a quick example. Here's the data set. The first step is to find your mean, add them all up, divide by how many there are. Then some people use a table. So you have your data points. You subtract the mean. So in this case, every single one minus 9. And that gives you that difference. You square it. Okay, so that's squared. Then add them all up. You get 86. That 86 is the summation. Divide by how many there are. And we have a variance of 17.2. We take the square root and we get a standard deviation of around 4.15. Okay, so those are the sort of the numbers. Yeah, out of context, they kind of like a little awkward. But once you start seeing them and comparing data sets, you start to realize, oh man, we really like those numbers. They really tell us a good story. I'm going to throw this in. Now, no, don't worry about any of this. I just want to kind of bring your attention to this. This sure looks a lot like the variance. Yep, we take every data point minus the mean and we square it and we add them all up together. But instead of dividing by n, we divide by n minus 1, which makes this smaller denominator, which makes this a little bit bigger. Okay, a little bit bigger than the standard deviation. We call this the sample standard deviation because when you have a sample trying to represent a population, you just don't really, maybe we could just, if we subtract 1, maybe it'll make it a little bit bigger so it's a little bit more, kind of covers the population. That's a very, very, very 1-minute explanation of something that people that have doctorates in statistics would just have a field day talking about the mathematics behind that. It's really fascinating, but you know, you really can kind of generally relax a little bit and just kind of say that's why. Um, it's pretty cool. It's pretty cool looking into it. I've definitely sat down with some people and had them try to explain all the nuances of that formula, but I think it's safe to just say, uh, and sometimes it's called the unbiased estimate of the population standard deviation. Not worried about that. Why would I bring it up? We're not even going to really use it. I bring it up because of the calculator. Okay, the calculator, when you plug stuff in, we've done this hopefully enough where you find that the calculator finds a lot of cool stuff for you, and that top number is the mean. The notation they give you is X bar, but we will also use that to estimate the population mean. And then it gives you two values for the standard deviation. Okay, um, the bigger one is the sample standard deviation, and the bigger one is the population standard deviation. But Mr. Sayers, which one do you want when you ask? I just want the population. Okay, I just want the population. Standard deviation. Well, maybe if you scroll down, you're thinking, well, where's the variance? He's probably going to ask for the variance and the standard deviation. The calculator does not give you the variance. So what you need to do to get the variance is take your standard deviation, you're going to square it, and that is the variance. So when we do it by hand, we calculate the variance first and then take the square root to get the standard deviation. When we use a calculator, it kicks out the standard deviation, so that means we have to square it to get the variance. I think I said that right. I'm going to just repeat, make sure. By hand, we calculate the variance, and then we take the square root of that to get the standard deviation. When we do it with a calculator, plug in the numbers, it gives us the standard deviation, and we have to square that to get the variance. All right. Uh, yeah, so sometimes you really luck out and get a ton of numbers. You are just plugging that in. The TI-84 is a popular graphing calculator. There's your mean, there's your sample standard deviation, and there's your population um, standard deviation. I would square the population standard deviation to get the variance. Um, Anybody who's taking IB math, what we're going to be doing is we're going to kind of assume everything's dealing with populations. That sure makes things easy. All right, number one, we're already done with the notes. The data set is right there. Show that each, so if you notice, this is the data set I already did. To find the mean, we just add them, divide by how many there are, 6 in this case, and we would get 8. Great. I would say this one has a bigger spread, 1 to 14, where this is only 5 to 10. So I would expect the standard deviations to be a little bit bigger in this one and smaller in the 5 to 10. So that's maybe how you calculate that. Now you can do this by hand in these small sets. If I did data A, if I want to find the variance, then I would find the sum of all these. I know the mean is 8, so it'd be 10 minus 8 squared plus 7 minus 8 squared plus dot 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 plus 10 minus 8 squared again, all over 5. And that'll give me my variance, and then I take the square root and I'm good to go. So calculator, let's talk about it real quick. If I do this in a calculator, you notice that I've plugged in the two sets already. If I want to find all the good stuff here, I go to Stat, I go to Calc, it's one variable statistics, hit enter, and enter. So there it is, the mean's 8. Like I said, the standard deviation is 1.89. So I'm going to just look at the population, 1.89. That's pretty cool. Maybe I can write it right here. 1.89 is the standard deviation of data A. And if I go back, if I want to find all the stuff for the other list, I'll show you the list again. For list 2, then all I have to do is stat, calc, one variable statistics, but now I have to tell it's in list 2. You guys with the nicer calculators kind of have that, and it's written there right there, and it's assuming it's list 1 usually. So remember, you hit second and then the number of the list. So in my case 2, which I don't think you can see, that I'm plugging that in, hit enter, and there is again my mean of 8, but this time the standard deviation is 4.65. 4.65. So data set B has a sigma of 4.65. Hey, if I want to find the variance, well then I just square those numbers and I get the variance. Good luck. Kept it under 17 minutes. Come on. Now, if I did this again and again, it would probably average a little bit more than that, or maybe less. I don't know. We should do it. All right. Have a great one. Have a good weekend. We'll see you Monday.